Hey guys, today we're going to be talking about mathematical induction. So this is a really essential topic in maths and just you can use in a lot of places and you're probably going to come across it if you study math at a high level like past middle school or high school. So it's essential that you know this topic. So I saw this in an example online and I wanted to explain. I wanted to teach how you guys might be able to solve this question and how you may come across and like how you may answer this if you see a similar sort of question in your exams or your studies or even if you like math in general, like in a passionate way. So over here, we have to prove that this belongs to all n belonging to this is symbol, it's called zeal. I don't remember the exact thing, but when it means this, it just means it's a positive integer. First, you're going to talk about let P of n be the following. So we're going to take the first positive integer, which is 1. So let n equals to 1. So over here, we're going to use the right side. So it'll be 1 minus r to the power 1 plus 1 divided by 1 minus r. So it'll be 1 minus r squared upon 1 minus r. So this is another rule. You guys should know a bit of algebra, but a square minus b square can be written in the form as a plus b into a minus b. So 1 plus r into 1 minus r divided by 1 minus r. Now, if you know, you can cut these out. So it'll be 1 minus r, 1 minus r. This leaves us with 1 plus r. Hence, p of 1 holds. Okay guys, so now we're going to equate n equals to k. So we're going to just do this. 1 plus r squared, then it goes all the way up to r to the power k now I guess, and it's going to be 1 minus r to the power k plus 1 divided by 1 minus r. This will be for some k is greater than equal to 1. Now it's going to be the inductive step. We're going to use the inductive step. This is the third step. It's a really crucial step, and you should have some prior indices. Like you should know how they work and how we solve like algebra and like just like basic stuff because we're going to use a lot of this, like especially in the third step. So over here, let's equate n to k plus 1. So this is essential. So it'll be 1 plus r squared plus, then you can go like this, plus r to the power k. But now because n equals to k plus 1, we can add this also. And this would be equal to 1 minus r to the power k plus 1 plus 1 divided by 1 minus r. Now you think about it, because this is equal to this, we can put this in a bracket and we can insert this over here. So 1 minus r to the power k. So let's handle this part. Let's handle this for later. Let's talk about this. 1 minus r to the power k plus 1 divided by 1 minus r. And then you're going to add this with r to the power k plus 1. Okay, now over here in the denominator, we have 1 minus r. And to further solve this equation, we have to multiply this with 1 minus r to make the same denominator. So 1 minus r to the power k plus 1 plus r to the power k plus 1 into 1 minus r divided by, and we can make this the same, so divided by 1 minus r. So what we need to do here is let's multiply this. Let's do this on the side. R to the power k plus 1. Let's talk about minus r. So this will be minus r is basically power minus 1. Yeah, I guess. So over here, we're going to be talking about, let's equate this. So plus odd power k plus 1, and this is minus all. So what we're going to do here is minus odd power 1. So divided by, this will be minus odd power k plus 2. Let's think about this. So we're gonna, this will be minus and the whole thing. So into odd power 1. When we do 8 to the power 2 into 8 to the power 5, it becomes 8 to the power 2 plus 5, so 8 to the power 7. So we're gonna add these two. So k plus 1 equals to k plus 2. Okay, now we got this, and I'm sorry, but it's gonna be minus here. So these two cancel out. So this will be equal to 1 minus odd power k plus 2 divided by 1 minus odd. Okay, we got this. So that just means that if we, now, do you remember when I said later for this? Let's make this simpler. 1 minus odd power k plus 1 plus 1. K plus 1 is just k plus 2. K plus 2 divided by 1 minus odd. This just means that this is the right hand side and this is the left hand side. So this means that LHS equals to RHS. So the left hand side becomes equivalent to the right hand side. Let's put them side by side. Is there any difference? So there's no difference. They're the exact same. So we just prove this. So we're just going to write hence P of k plus 1 will hold. Now, especially, I'm not sure about other curriculums, but especially in the IB, the conclusion does have a certain weightage into your answer. So you can write this as the conclusion. Since P of 1, this is when n equals to k, n equals to 1, is true, and P of k plus 1 is true whenever the P of k is true. So henceforth, P of n will hold for all n belongs to positive integers. This is essential, guys. P of 1 is when n equals to 1. This is the first step. Our second step was P of k, which is the inductive hypothesis. We just have to equate it, and the inductive step is the hardest step. But if you understand it and you just read the question properly, there are a lot of great resources online, just like boost your curiosity, and just like if you get some extra learning, I think you all can do really well. Thank you for watching the video, guys. I had a really good time today. Thank you.